Ladies and gentle soars, welcome to Assessing Survival, the series where we take creatures from both our world and fiction and place them in different periods throughout history as well as different realities. In today's episode, we will be placing the North American beaver, Castor canadensis, in North America during the Muscovian of the Late Carboniferous 310 million years ago. I will be using 4 different categories to assess the beaver's ability to survive. The scores for these categories will then be added up for a survival assessment score, and towards the end of the video, we'll speculate on how the beavers may change or adapt to better fit their environment, regardless of their score. So without any further ado, let's start our assessment. Would they survive? Today, the North American beaver's range stretches from the Bering Strait all the way down to northern Mexico, making them pretty adaptable. However, they primarily reside in temperate wetlands and forests. They thrive in stable environments with suitable rivers and marshes for dam building. The Carboniferous period experienced a significant cooling event during the early Pennsylvanian, resulting in a humid but relatively mild climate. Much of the land during this time was covered in warm, temperate wetlands and rainforest, with temperatures floating around 24 to 26 degrees Celsius. Not too dissimilar to the wetlands beavers inhabit today, but of course the majority of, if not all of the plants in these ecosystems would be wildly unfamiliar. The landscape was dominated by strange tree-like ferns, giant horsetails, and dense vegetation. Additionally, many of the fossilized plants from this period lack growth rings, suggesting a stable, uniform climate with little seasonal variation. Normally, I don't mention oxygen levels in this series, and that's because in most scenarios the difference is negligible between 2 time periods, but any video surrounding the Carboniferous needs to include some discussion around oxygen, as it's a big part of the reason the giant bugs this period was known for came to be so large. Today, beavers comfortably breathe in an atmosphere that consists of roughly 21% oxygen. They and most modern mammals would probably be able to breathe in as much as 26% oxygen with only positive effects. Their blood and muscles would become more saturated with oxygen, allowing them to dive for longer, mature faster and recover quicker, and generally burn energy more efficiently, possibly giving us slightly larger beavers with extended lifespans over generations. However, for most of the Carboniferous, oxygen levels seldom fell below 30%, peaking at 35%. While higher O2 levels would continue to benefit beavers in these ways, it also begins to affect them negatively. They would experience an increase in oxidative stress, which has a chance of damaging cells, shortening lifespans, or leading to cancer and neurodegeneration if not balanced by an increase in antioxidants. While that may sound pretty bleak, these effects would take many years to adversely affect an individual, and mammals are known to adapt to drastic environmental changes over a relatively short amount of time. After all, mammals did develop during the Mesozoic, for much of which the O2 levels were a fair bit higher than they are today. Today, beavers aren't quite so agile on land compared to other rodents, but they are fantastic swimmers thanks to their webbed feet and paddle-like tail, the latter of which they can use to pack down building materials or smack on the surface of water to intimidate other animals and signal danger to other beavers. Their hands and feet, despite being webbed, are quite dexterous and can be used to manipulate building materials. Their fur is made of 2 layers, a soft underfur that traps air and insulates their bodies, and a top layer of coarse, guard hairs that create a waterproof seal around the animal, allowing them to swim gracefully, but not without the help of castoreum, an oily substance secreted from 2 sacs located near their derriere. The beaver's iron-coated teeth allow them to chew through hardwood like oak without the fear of breaking or wearing down too fast, something that actually might cause an issue given the lack of dense angiosperm trees. Beavers may need to seek the hardest of plant material or find alternative ways to wear down their chompers. Though this is certainly easier said than done. Something that might make the search for viable plants to eat a little bit easier would be the internet browser, Opera. I myself have already been using Opera for close to 2 years now. Their Tab Island feature, which allows you to create expandable and collapsible groups of tabs within the browser, has been incredibly useful for keeping myself organized during research. Opera's built-in AI tool, Aria, can also help you with your tab organization. You can quickly access Aria's command line with a few simple keys, and write a prompt to organize these tabs just like so, or close all your YouTube tabs with another command prompt. Let's say one of our beavers needs to identify one of these plants to figure out if they're safe to eat. They can take a picture of it with the cell phone they definitely have, and have Aria's image recognition analyze and identify it. I personally like to have a little music or podcast playing while I work, and Opera's floating music player lets me control what I'm studying or jamming to, even outside the browser, with 7 different streaming platforms to choose from. With Opera's theme gallery, you can choose between their dynamic themes like Aurora, Midsummer, and Viking, with further customization options to personalize your browser. If these features made you say, damn, all you have to do to get started is click the link in this video's description or pinned comment to download Opera for free. Behind their teeth, beavers possess a second pair of lips or oral flaps, which form a seal to keep them from choking while chewing or moving material underwater. But above these previously mentioned strengths, the beaver has 2 that will really stand out in the Carboniferous: their reproduction strategy and their tendency to, upon hearing rushing water, go, "What is that terrible noise?" and block it off with several months of construction in order to make way for residential zoning. Gestation provides a few advantages over egg laying. The mother's body offers a constant, controlled environment for the developing embryo, protecting it from nest raiders, extreme temperatures, and other external threats. This safety grants a longer period of development, meaning they can be born larger and better equipped to survive. A newborn beaver, called a kit, can swim within 24 hours from birth, and start eating vegetation in less than 2 months. Speaking of their parents, beavers are monogamous and pair for life. Not only is this based, but it also allows beavers to work in shifts, sharing the responsibilities of dam and lodge upkeep, food gathering, and protection of their kits. The longer 2 beavers are paired and the more litters they raise, the more successful they are. And of course, there are the dams and lodges themselves, the latter of which is where beavers live and raise their young in, creating a place of solitude from predators and adverse weather. Beavers today are the single most important animal when it comes to the conservation and propagation of wetlands, as they will build dams to slow and block off running water, redirecting it into the surrounding terrain. This action not only creates the environment necessary to create their lodges, but stimulates the growth of a wetland ecosystem that further separates them from their predators like wolves, wildcats, and D.R. Horton developers. In the event beavers cannot find a suitable pond to build their lodge here in the Carboniferous, they can simply block off a stream or river and terraform the environment around them. In the Carboniferous, there aren't so many threats coming from dry land as there are from the water. Large temnospondyls, invertebrates, and predatory freshwater fish would be abundant compared to the odd alligator or snapping turtle large enough to prey on adult beavers, and those are animals they'll only encounter in the southern parts of their range. Bears are their only regularly occurring threat in the water, and in the event a bear attacks their lodge, they can escape quite easily. While the Beaver Lodge is still an impressive fortress, it's going to be a little less useful in the Carboniferous. Tool use, as seen in animals like crows and apes, is generally considered a benchmark for high intelligence in the animal kingdom. And while beavers aren't especially known for using tools, it's pretty clear that they're very intelligent. Other than humans, there really is no mammal that builds quite like the beaver. And do you really need to use tools when your body just is one? The beaver evolved on a planet dominated by angiosperm and gymnosperm trees. Their diet consists of cambium from trees like maple and oak, aquatic plants like water lilies, cattails and pondweeds, and things like leaves and grasses. In the Carboniferous, the plant biosphere was dominated by giant horsetails, club mosses, and seed ferns, with conifers only starting to show up to the party. While these towering pseudo-trees of the Carboniferous are probably softer and their cellulose structure would be easier to break down, these plants contained high amounts of lignin, a complex, tough, and indigestible polymer found in plant cell walls. While beavers can extract nutrients from plant material with high amounts of lignin, it'll be more intense on their digestive system. Lignins are present in modern plants as well, of course, but the anatomy of the plants themselves are quite different, which means the beavers will have to do a lot of learning to find out which plants have the most nutrients for the least amount of lignin and where. While it would be a big change and take a lot of effort, the beaver's gut microbiome is tuned for breaking down tough plant material and extracting nutrients from it. It would again be a matter of adapting to conditions over generations, only this time for the digestive system rather than their cardiorespiratory system. Like we said earlier, beavers in the Carboniferous have far less predators to worry about on land, But conversely, there is no shortage of aquatic predators, the main threat being amphibians, the three largest of which are as follows: Megalocephalus, Neoterraplax, and Adamanterpeton. Megalocephalus was semi-aquatic and was the size of a small alligator at 1.5 meters in length. It likely preyed on fish, aquatic invertebrates, and smaller amphibians. While they're certainly not large enough to be a regular threat to adult beavers, they could definitely prey on their kits. Neoterraplax was twice as large at 3 meters or nearly 10 feet in length. This animal too would have fed on fish and amphibians, but killing a young or even adult beaver would certainly not be out of the question. And then there's Adamanterpeton, a massive but mostly terrestrial temnospondyl the size of a boar, with a skull as large as a human torso. This predator could easily prey upon a beaver with its sheer size. Despite its more terrestrial lifestyle, it would certainly be capable of getting into the water and chasing them down. Large freshwater fish, such as relatives of Rhizodus, the largest freshwater fish in history, who went extinct in a previous epoch, could still be lingering around, and if so, may be large enough to swallow a beaver whole. The saving grace for these beavers, though, with the lack of large herbivorous tetrapods, is that the only other animals who fill a similar niche are ones like Melanedaphodon, Desmatodon, and Arthropleura. Melanedaphodon was a squirrel-sized omnivorous edaphosaurid and among the first synapsids to show up in the fossil record. Certainly it wouldn't be much competition, but it puts into perspective just how few vertebrates were capable of digesting plants at the time. Desmatodon being a rather small diadectid and one of the earliest herbivorous tetrapods, in fact the earliest fully herbivorous tetrapod that we know of, and the Wikipedia page has a picture of a plant on it. Hello? Someone with editing privileges at Wikipedia, please fix this, man. Arthropleura, arguably the mascot of the Carboniferous, was a huge herbivorous tank of a bug that ate from the swamp floor. And while there would be some small overlap in its diet and the beaver's diet, interactions would probably be rare, and in the event that they do run into each other, Arthropleura's size and mass would likely persuade the beaver into finding another spot to eat. When combining the scores for all categories, the North American Beaver Survival Assessment Score comes out to 7.3 out of 10. Barring some challenges with adapting to a new diet and atmosphere, the beavers are hardly worse off in the Carboniferous than they are today. In fact, in a few ways, they're much better off. Of course, their biggest hurdle is finding new plants to make up their diet, and these plants that are available to them are quite different from those they eat in the modern era. The introduction of beavers into the Carboniferous has long-lasting implications for the fossil record going forward. As far as we know, there were no large herbivorous vertebrates chowing down on trees and other plants to the same degree something like a beaver would, and certainly not one that propagates wetland ecosystems. The Carboniferous rainforest collapse, the extinction event that occurs towards the end of the Carboniferous, was triggered by massive glaciations in Gondwana and a shift towards cooler, drier climates globally, a trend that continued into the Permian. However, the presence of beaver populations could stabilize rainforests and wetland ecosystems locally, creating pockets or island of pre-collapse rainforest throughout their range. Who knows how far the effects would cascade, but for now we can have some fun like we usually do and come up with some ways these animals could evolve in the short term. Free from predators like wolves and bears, many beavers became more comfortable with life on dry land, and spent longer hours feeding on the low-nutrient, lignin-rich plants that covered the Carboniferous rainforest. The nature of these plants required the beavers to eat much more of them to reach their nutritional needs, and so they adapted to do so. The Sibilibuca castor, whose name means the whistling cheek beaver, is the result of countless generations wherein traits suitable for long days of browsing were selected from our original, more land-inclined beavers. The Sibilibuca use their large incisors to pull vegetation off of plants like calamites and walshias. This dietary choice has also resulted in a massive uptick in size, reaching an average height of 1.5 meters at the shoulder and a body length of 3 meters. The fleshy second pair of lips seen in their ancestors are now articulated in such a way that allows them to form a hole small enough to whistle through. This is usually used for locating family members or as a distress call in the event one of them is attacked. You may have noticed that this beaver's tail is tightly wrapped around their rear end. This is where the cheek part of the name comes in. Sibilibuca will lift their wide tails up and swiftly smack them against their own rear end to create a loud clapping sound that can be heard as far as 8 kilometers away. This behavior is reserved for displays of aggression, broadcasting ownership of territory, or signaling to potential mates. So, one could say that these beavers clap cheeks in order to clap cheeks. Much like their ancestors, Sibilibuca are monogamous, and mate for life once they find their match. Unlike modern beavers, however, they do not build dams or lodges. Rather, they will build small, temporary huts around the base of a tall tree in order to raise their young towards the end of their gestation, as their lifestyle requires them to be on the move. Whistling beaver calves are born much larger and as a result will now take almost 14 months in order to develop in the womb. After joining the world, these calves will remain in their nest for only 4 to 6 months, wherein they'll join their parents as wandering nomads. Few creatures could take advantage of beavers as prey as readily as Adamanterpeton. With the onset of large, land-dwelling herbivores like the whistling beaver, descendants of Adamanterpeton would become another reason the beavers got as large as they did. Paludovorax crosswicki, whose name means Crosswick's swamp devourer, was nature's answer to this temporal displacement. The Sibilibuca, in all of their hunger, cleared out vast areas of rainforest that many species called home. The Crosswick monster, inspired by the Appalachian cryptid of the same name, differs from other temnospondyls in its ability to be without moisture for long stretches of time, as well as holding itself in a more upright but still sprawling posture like animals later seen in the Permian. The Crosswick will stay in burrows in moist soil, but upon catching the scent of the whistling beaver's castoreum in the wind, they will readily advance towards their prey. Reaching a height of just under a meter and a little over 2.5 meters in length, they do tend to struggle with adult Sibilibuca, as the beaver's claws and teeth can do a number on their largely unarmored skin, and their powerful tails could easily leave a Crosswick with a fatal injury. The calves, however, are easy pickings. The Crosswick strategy is as follows. Stalk a Sibilibuca family, and wait for a calf to be either unattended or a little too far from its parents. Then, rush in and grab the calf, biting it on its back in order to avoid its claws and tail, lift it above your head, and run back into the forest to eat your meal. Beavers were already quite clumsy on land, and the Sibilibuca are similarly awkward due to their size and relatively new lifestyle. The Crosswick is much faster in bursts and can better fit through the tight spaces of the rainforest, which makes preying on their calves relatively easy. The Crosswick won't have to eat for more than a year after this meal, and the whistling beavers will take more than a year to create more offspring. Ordinary beavers still lived a relatively comfortable life, building their dams and lodges. As the Carboniferous rainforest collapse went on, these beavers maintained the rainforest environments in localized pockets that would have otherwise become much drier. They did so by redirecting streams and draining ponds into the surrounding areas in order to propagate more wetlands. Beaver kits often stuck around to continue helping in the efforts of building dams. Instead of establishing their own territory when finding a mate, beavers would bring their mates back to their parents' lodge, creating generational households of sort. And these households' territory became large enough to overlap with other beavers, who were working towards the same goal. The collective effort of these different beaver colonies coalesced into a sharp spike in brain size in a relatively short amount of time. The beavers that came about as a result would be known as Castorinomus nittani, meaning Nittany's beaver gnome. The beaver gnomes live in large colonies made up of many households that are either in or around ponds, depending on the region. These households are massive, multi-leveled lodges where beavers rest their heads and raise their young while not working. They spend the vast majority of their time contributing to what would be called the Big Wet if they had a language. Honestly, I'm not too sure if they actually do or not. It kinda seems like they do Anyway, the Big Wet is a subconscious drive within the beavers to create as much wetland as possible. They may not have a concept as to why they're doing it, but they certainly know that they have to. They take it so seriously that they even work in shifts, with young males and females taking the early morning to afternoon shift, and mostly older males taking the night shift, while nursing females take care of their kits. Households resemble small, multi-floored beaver lodges with several chambers dedicated to a single mating pair and their kits. These lodges, usually located on land rather than in the water, are topped with the chitinous plates of Arthropleura, who the beavers have prevented the extinction of by proxy of maintaining carboniferous rainforests. These plates act as shingles, letting water slide off the roof of the household, but still allowing for some moisture to soak in. They even grind up the chitin of Arthropleura to make a cementing paste, which greatly increases the integrity of the structure. The beaver gnomes worked towards the Big Wet for untold thousands of years, but for all their efforts, they and any other descendant of our displaced beavers, and 80% of species on the planet, would go extinct before the beginning of the Middle Permian. If you enjoyed this video, leave a like, a comment, and subscribe if you haven't already. Thank you guys once again for tuning in, and until next time.